Greetings and welcome to Extra Class. Today we are going to be on the second chapter in our Geography Form 1 lessons. We are going to be looking at landforms and landscape processes. The Earth's surface is always going through some changes. These changes are caused by natural forces which can lead to processes such as plate tectonics, erosion, earthquakes, volcanoes, faulting and folding. But human activities also affect landforms. In this chapter, we are going to be identifying these landforms, describing them, and also to distinguish the landforms. Landforms, what are these? These are the natural geographic features which determine the shape of the land surface. These appear in different sizes and shapes. Across Zimbabwe, wherever we are, there are several landforms, which include plateaus, balancing rocks, towers and hills. The study of landforms is called geomorphology. It studies the origin, development, and history of landforms, and scientists who study landforms are called geomorphologists. Landforms are formed by processes such as plate tectonics. Plate tectonics is the large-scale movement of crustal blocks called plates. These are the slabs where continents and oceans are sitting on. They move along their margins, and as a result, they create landforms. The second one is called faulting. This is the breaking of crustal blocks due to forces such as tension, compression, and tear. Okay. Third, folding. This is the bending of the crustal rocks. Earthquakes. Earthquakes are sudden vibrations of the Earth's surface as a result of plate movement. So here is what forms the landforms. These are the processes which forms the landforms. We also have erosion. Soil and weathered materials called regolith are washed away, and this process also helps to shape the landforms. Weathering, it is the breaking down of rocks into smaller particles. Lastly, volcanic eruptions. Magma is ejected onto the surface to solidify and to form landforms. Now, you are going to learn more about some of these processes in the next year or 2 years until you are done with your O-level studies. In some areas, in areas of granite rocks, there are some common features or landforms. So let us now look at granite landforms. In areas of granite rocks, the common features or landforms are as follows. Castle copy or towers. Castle copies are small hills made up of piles of rocks. Have you ever seen rocks like these ones, which looks like balancing rocks? Those are castle copies. Large rocks sitting on top of each other with large rectangle-like rocks. Though there has been attempts to distinguish castle copy from towers, the features are just the same. The difference between them is very small, such that the terms are used interchangeably. So in your revision exercise, if you see castle copy or towers, it is one on the same landform. Dwellers or ruare in Shona. A dweller is a dome-shaped, low-lying bare rock that is a dwala. Bonehart, these are tall, steep-sided hills made up of rocks. The rocks may contain joints or cracks. Limestone landforms. So landforms formed on limestone rocks are called karst landforms, and these include underground caves. These are also called caverns. They are caves formed on limestone rock due to processes such as solution. So solution, this is a process whereby the limestone rock is slowly and gradually melt due to chemical reactions. A good example of underground caves in Zimbabwe is the famous Chinhoyi caves. Limestone pavements. These are ridges separated by furrows. The ridges are called clints and the furrows are called cracks. Sinkholes, door lines, podge, and uvalas. These are depressions or low-lying points found on limestone surfaces. Sinkholes are depressions on limestone surfaces. Water accumulates in rock joints and weak acids such as carbonic acid dissolves the rock along the joints. The depression develops such that streams end up sinking into the ground on such depressions. The sinkholes grow to become bigger depressions called dolines, podges, and uvalas. River landforms. River experiences erosion, transport, and deposition, and these processes lead to the formation of different landforms along the river profile. The landforms formed by rivers include waterfalls and rapids. Rapids are sharp breaks along the course of the river, which causes water to flow rapidly to a lower gradient. Usually, rapids grow to become waterfalls, and waterfalls and rapids are formed when water flows rapidly to a lower gradient in a channel. The rapid flow is a result of a resistant rock being slowly eroded than a weaker rock just below it. This causes water to flow rapidly from a high resistant rock to a lower level. The steep slope is caused by the erosion of a weaker rock. Examples of waterfalls in Zimbabwe includes the Mutarazi Falls and Victoria Falls. So basically what we have here is, let's say we have our river which is flowing this way, but along as time goes on, there will be a very hard rock. Let's say here is our granite rock which is resistant to erosion. So as the river falls, it will erode every other places, but it cannot erode our rock. So it will end up falling like this, creating a waterfall. It is because of this rock which is resistant. This rock which is resistant will cause the water to come and fall. This is how a waterfall is formed. Oxbow Lake. Oxbow Lake is a C-shaped or a U-shaped feature formed when active erosion at the neck of a meander. So in river studies, a meander is just a bend. When a meander cuts off the meander and take a straight course, leaving the meander separated from the meandering segment of a river, erosion is active and at the neck of the meander. With time, that active meander will break through the neck, enabling the river to avoid meandering or bending to make a straight course. The meander is left out without supply of water from the main river, hence it ends up drying. So just a simplified diagram. We have our river flowing like this. So at this point there is erosion. Erosion will be happening at this point. Then it will continue eroding up till it is such like this. See? So when it is like this, it will continue eroding again until it breaks these two. When it breaks and joins straight line like this, we can say this is now an oxbow lake. This one will be an oxbow lake. Look at these two sides. They look like the horns of an ox. That is why it is called an oxbow lake. Let's proceed. So this is how an oxbow lake will look like, but at this point this is a fully developed oxbow lake where we have this part which is cut off from the main river. Braids. Braids are small islands found within the river channel. The river splits into two or more channels that later on joins. They are formed when deposition occurs within the channel. Levee. These are ridges of sediment deposited just outside the channel. During river flooding, or when the river is flooding, water will overfill the channel and some of the load is thrown outside the channel. The biggest particles are deposited first, just outside the channel. Smaller ones are deposited later when velocity decreases. Hence, these are found on top of coarser sediment. Some small sediment are carried further away from the bank to the channel into the flat plain. So here is what we are talking about, levees. These ones are the natural levees caused by deposition of sediment. Floodplain. These are gentle sloping surfaces on the sides of the channel. The floodplain is the surface on the sides of the channel which is covered by water during flooding. So during flooding, the river deposits alluvial deposits on the floodplain. The floodplain may contain features such as marshes, alluvium, meanders, and oxbow lake. So in basic terms, let's say we have got our stream here. Here is our very simplified river that is flowing, but then it rains. You have too much rain, then it will overflow to occupy all this adjacent space when it rains. So all this adjacent space is called the floodplain. This is where the river will overflow when it is flooding. If you notice, many rivers have got floodplains. So let's proceed to volcanic landforms. Volcanic eruptions form extrusive and intrusive landforms. Extrusive landforms are formed at the surface, whereas intrusive landforms are formed underground. Let us turn now our attention to these two types of landforms. Extrusive landforms. We have volcanic cones. A volcanic cone is a triangle-shaped hill formed by volcanic material accumulating around the vent. So a vent is actually the mouth of a volcano. A vent is an opening through which molten rock, gases, lava, and rocks erupt. There are various types of cones, which include composite cone, ash and cinder cone, and shield cone. These different type of cones will be discussed in detail in coming years. Geysers and hot springs. A hot spring is the emergence of naturally heated water from the ground, and geysers are hot springs that intermittently sprout a column of hot water and steam into the air. Geysers and hot springs are formed in regions of young volcanic activities. So water percolates into the ground to reach a region of high temperature around the magma. The water is heated by the magma and it forces its way through the cracks to the surface. When the water is ejected to the surface, it forms a geyser, but if it is not violent, it may appear on the surface as hot springs. So here are some examples of geysers. The Fly Geyser in Nevada, USA, Loburu Geyser in Kenya. Examples of hot springs are Binga, Kariba in Zimbabwe, Lubimbi, Matabeleland in Zimbabwe, then hot springs in Manicaland, and Burunga hot springs in the eastern part of Africa. Caldera. Caldera is a large volcanic crater which may form a lake. They are different from a normal crater in that calderas are very big. They are found on top of volcanic hills after the collapsing of a volcano. There are different types of calderas which include crater lake caldera and subsidence calderas. Desert landforms. Wind and water lead to the formation of different landforms in arid areas or deserts. So arid areas are also called deserts. The features formed by wind includes the following. Deflation hollows. These are depressions found on the surface of a desert. Loose material are removed by wind gradually, leaving a depression. Once small depression develop, eddies will become active, thereby enabling the depression. Capillary action will loosen the soil as the prevailing wind blows over the loosened soil, removing the loose soil. Once the loose soil has been removed, a shallow depression is left behind. The depression and the wind is blowing over to experience eddies. A deflation hollow is formed when wind continually blows over the depression hollow. Rock pedestals. Rock pedestals are mushroom-shaped features which develop in arid areas due to abrasion. So abrasion is an action of wind that is carrying loose material and it rubs against the sides, like in this case, the sides of a rock feature, and slowly eating it away. The wind blowing causes sand blasting. So the wind must be carrying soil particles and then it will sand blast. Thereby, sand is used to polish rock surfaces. Rocks which are made up of alternating resistance. The weaker layers are eroded faster than the resistant layers. This will produce a feature called rock pedestals. So as you can see here in this picture, it seems as if abrasion was most active towards the base of this rock. This is because towards the foot of the rock, the sand particles blasting the rock are very much. This is why the rock is cut deeper near the surface. There is a lot of sand coming at this height. So because abrasion is greater near the surface, the lower part of the rock is eroded faster than the upper parts, producing this feature which looks like a mushroom. Yadang. These are ridges made up of resistant rock layers separated by troughs where less resistant rocks has been eroded. Yadangs, they lie parallel to the prevailing wind. A yadang is caused by abrasion, which results in wearing away the less resistant layer, leaving the resistant layer standing as ridges. So from your study of wind, you know what is a prevailing wind. So the prevailing wind will start off, let's say our surface is like this. Then as the wind blows, now we have got resistant layers underneath. So the wind will start to erode away parts of this. So they will start to erode all these weaker rocks. The resistant rocks are left. This is a resistant, this is a resistant, this is a resistant. So as abrasion continues, we will get ridges that look like this. Yes, where this is the resistant rocks, they form ridges. This is a resistant rock, this is a resistant rock. So these are the troughs which are formed due to the abrasion effect of prevailing wind, forming yadangs. Zugens. These are ridges and furrows found on the surface of deserts. They are a result of abrasion. In this case, the resistant rock is overlying a less resistant rock. Therefore, the resistant rock develop cracks due to weathering. These cracks enable the wind to access the less resistant rock below. The less resistant rocks now is worn away to create furrows separated by ridges of remaining resistant rocks. Sand dunes. These are molds of sand found in deserts. They appear in different shapes and sizes according to how they were formed. Their size also varies, with some reaching over 100 meters high. The most common type are Bakan, Sif, and sand ripples. So what is a Bakan dune? Bakan dunes are crescent-shaped molds. This is the crescent shape. Okay, and sand molds of sand lying right angles to the prevailing wind. So the prevailing wind is coming from this direction. They are formed due to obstacles such as vegetation, rocks, and dead animals trapping sand behind them. The sand accumulates behind the obstacle, leading to emergence of a crescent-shaped feature. So maybe a tree is here, so it will accumulate sand behind it. Right, let me draw a very simple diagram. Here is our tree. The wind is blowing from this side. It brings sand. The sand will start to accumulate here. Then when it accumulates, it will overflow to going to this side and also coming to this side. And over time, more sand will accumulate, and then we end up having a Bakan dune, which looks like this. This is a Bakan dune, and it will be moving due to the wind action. Sand ripples. These are small wavy features found on desert surfaces. They can reach about a meter in height. These tend to be temporary because when the wind changes direction, sand ripples are destroyed. Ventifacts. These are also called faceted pebbles or decanters. They are smooth, well-polished rocks. Abrasion, which is a wind action, polishes the rocks such that they become very smooth and slippery. Loess, these are sand particles carried in suspension over very long distances before they are finally dropped. The particles can travel for hundreds or thousands of kilometers before being dropped. Wadi, these are deep, steep-sided gorges found in deserts. The movements in the Earth's crust called plate tectonics also lead to the formation of different landforms. Examples of plate tectonic movement are faulting and faulting. These processes form different landforms. Some of the landforms formed by such movements and other geographical processes includes valleys. Valleys are low-lying places between mountains. Plateau. A plateau is an area with steep sides and a flat top. For example, the Jos Plateau in Nigeria and the Zambezi Plateau. So this is a plateau. It has got a flat surface, steep sides, and this scree. Cliffs are steep faces of landforms. For example, the steep face of a hill or a plateau. So here's a cliff. Mountains are common landforms, and the highest mountain in Zimbabwe is Mount Nyangani, which stands at 2,592 meters above sea level. Mountains are bigger and higher than hills. If the altitude is above 300 meters, it is referred to as a mountain. Hills are smaller than mountains. Hills are below 300 meters of altitude and they take different shapes. Conical hills are cone-shaped around highlands. They may be isolated from other landforms. We also have smaller conical hills which are called knolls or hillocks. Ridges, these are elongated highlands with steep sides. They stretch for several kilometers. Escarpments, these are the steep sides of a highland stretching to the foot of the highland. Escarpments are also called scarps. Gap, a gap is a low-lying area or depression between mountain ranges. Roads and rivers may pass through a gap. Lastly, passes. It is a deeper depression between two peaks. Gap and passes are way railways and roads. So we have got the Christmas Pass in Mutare, which is a depression between two peaks, and this is where mostly our roads have been developed along.